These ECM constant torque blower motors are really easy to troubleshoot, and I'm going to show you how on an actual unit. These types of blower motors are becoming very popular on air handlers and on gas furnaces. And you can tell if you have one because you'll see Spade connectors on the shell of the motor or on the end of the wires or on the end of the individual wiring coming off the blower motor, and you don't see an externally mounted capacitor. The other thing to note is that you're going to have two sets of wiring. One set's going to be for your power wiring, such as this right here. And you can notice this little blank spot, so you can plug that in right there. Here you have your power wiring right here, and in the lower section you're going to have your 24 volt speeds. And so over here you have a 120 volt version with your power wiring common, and then your 24 volt speeds along with your common. And so now I want to take it in and troubleshoot on an actual system. You don't have to remove the blower motor in order to troubleshoot these. In order to troubleshoot this, you remove the faceplate, turn the power off, and you're going to check to make sure that you have no power. So right here we have one probe in the L and one probe in the N, as you can see on this wiring diagram right here. And so we verified that we have no voltage, and we want to go ahead and stick our hand right in here and just feel to see if the blower motor is loose or there's some problem right there, maybe it's binding up. And so we can see that that's spinning freely. We're going to go ahead and disconnect this just in order to add a chair adapter. Basically, you're just adding something in order to get at the terminal to take your measurements. And so the whole point of this is that these 1 through 5 are all 24 volt speed connectors. And so right over here you can see 1, 2, 3, 4, 5. Now the manufacturer may or may not program these, but as you can see, we already had these in there from the manufacturer on those specified speeds. Now we're going to take our probes right here and we're going to put them back into our high voltage power wires. Let's turn the power back onto this air handler. So right now the thermostat's not calling for air conditioning or fan or anything to turn on, and this is correct. We have our high voltage power. In fact, actually the building's power is a little high at 250 volts. But now what I want to do is I'm going to stick this one probe in the 24 volt common right here. As you can see on the wiring diagram, it's right there. And we're going to stick our other probe in the number 2 speed connector for our motor speed. I've switched to our alligator clips just to make it a little easier to show. Now what we're going to do is we're going to connect our R and G, which are our thermostat wires. And so if you can see right here, R and G, that's going to turn the fan on. And you could just turn the fan on at the thermostat itself, or you can jump the R and the G wires together inside the unit. And you can see now we have 29 volts. If the blower motor does not turn on when you do have high power and 24 volts, you know your blower motor module is bad. And so the thing is, what you could do is you could also take this powered Spade terminal and go into each one of these numbered connectors and see if it's going to turn on. Maybe one of these numbers was not programmed by the factory, and that's the issue. And so we know number 2 is being powered. If this was not being powered, you could also put your probe on number 5 and check for voltage there. In this case, you can see that the number 5 speed is not being powered, only number 2 is. But since you see that the blower motor is running, you know that this one's good. It really is that simple. Do you have power to the plug? And do you have your 24 volt signal selecting which speed it's supposed to turn on at? Now this one's a broad ocean motor, and now I want to jump over to an X13 blower motor. Here we have an example of an X13 blower motor back here. We're not going to pull it out. We're only going to take this one speed wire out, and we're going to put this little chair adapter on. So we got our one clamp here, and we're going to put our other clamp on the common. Now we've turned our power back on, and we're going to put a call for the fan to turn on, and you can see we have a jumper wire on this gray wire, and so we can just jump right over to our R, and as you can see right down here, gray means fan. So you see we're measuring 29 volts, and the blower motor is running, so we know that the blower motor is fine. If we had 29 volts on here and the blower motor did not turn on, and we had power to the blower motor, and when the power off, this wheel back here was free spinning, it wasn't a problem, then we would know that we need to replace that blower motor. And so you don't just replace the module by itself, you do replace the blower motor as well. Here we have a 120 volt gas furnace, and let's look at the ECM motor taps. Now this is normally what it's going to look like inside of a 120 volt gas furnace, and you can just check for your 24 volts between common and fan, common and cool, or common and heat in order to determine if your blower motor should be running. I hope this video has helped, and if you want to learn more about ECM variable speed, ECM constant torque blower motors, PSE blower motors, make sure to check out some of the articles that we have over the website at acservicetech.com. We also have other training videos down in the description section below. And if you want to learn more about HVAC, make sure to check out our refrigerant charging and service procedures for air conditioning book. We also have a 1,000-question workbook and also quick reference cards that you can use out in the field. These are all available over at Amazon and also at our website at acservicetech.com. Hope you enjoyed yourself. We'll see you next time at AC Service Tech channel.